Welcome to the Smarter E podcast, a podcast for and with the creators of the new energy world. Hello and welcome back to the Smarter E podcast. My name is Zakas and I'm very much excited about today's topic because once again I get to talk about one of the puzzle pieces of the new energy world that has created quite some buzz around itself in 2020 and I think will still be one of the topics we'll talk about a lot in 2021, and that is green hydrogen / Power-to-X. Whereas in one of my previous episodes, we've already talked about the green hydrogen strategies of some of the countries in the MENA region, for example, Dubai. We've got some insights there from Cornelius Mattes of DII Desert Energy. Really recommend to check out that episode. In this episode, however, we're going to talk about Power-to-X in Europe. So you're going to learn some basic knowledge, such as, for example, what is Power-to-X really? What's the difference between green, blue, and grey hydrogen? But we'll also talk about the challenges and the more deeper conversation that comes with Power-to-X. So that means the significance of Power-to-X for the decarbonization of the European economy on the one hand, the potential for local manufacturers and the creation of jobs in Europe, but also the challenges or the threats that come with creating a competitive Power-to-X economy, because we've seen in the solar sector that it's easy to be ahead and to create jobs, but it's just as easy to lose them again if regulations or politics don't use the right leverages. Answers today will be provided by Dr. Carola Kantz. She is the Deputy Managing Director of the VDMA Power-to-X for Applications Working Group in Brussels. What does that mean? Two things. On the one hand, she is working basically for the largest industry association in Europe, the VDMA. And on the other hand, she specifically works for the Power-to-X working group that is comprised of more than 120 different industry players from that Power-to-X value chain. So all the way from the beginning, from manufacturers of renewable energy facilities over to electrolyzers, but also to manufacturers of engines or turbines, for example. And her job is to coordinate the cooperation, the research, but most importantly also to leverage some influence on regulations being formed in Brussels or Berlin. Welcome, Carola.
Hello, it's good to be here.
Well, it's great to have you on the podcast, Carola. Here in the Smarter E, we always try to make a mix between some beginner-level knowledge for those who are not familiar with the various aspects of the new energy world that we shed a light on, as well as some expert knowledge for those who are active in that specific sector we highlight. So in this case now, today, I would like to start maybe with the beginner knowledge. What do we actually talk about when we say Power-to-X, and why is it such a relevant and fascinating concept?
Thank you for this question. And when we talk about Power-to-X, we mean the whole value chain of converting renewable electricity, the power, into molecules. Obviously, you can produce hydrogen with an electrolyzer. And you can use the hydrogen directly, for instance, in the fuel cell, the chemical industry, for producing CO2-free steel. You can also use the hydrogen as a means of energy storage and re-electrify it in gas turbines. And this will be important in times where there's little wind or sun. But you can also convert hydrogen into other energy carriers. And this is what the X is about in Power-to-X. It can be climate-neutral gases, fuels, or other feedstock. To give some examples, by using Fischer-Tropsch processes, you can produce climate-neutral diesel and gasoline and kerosene for aviation. And with other processes, you can produce green methanol and ammonia. Now, the downside of these processes is that with every conversion step, you lose energy. But the upside is that you can use those gases and fuels with existing infrastructure. Take the example of synthetic kerosene. You could use this fuel already today as a 50% drop-in any plane, which would mean a 50% reduction of CO2 emissions in the aviation sector as of today.
Well, in my eyes, aviation specifically is one of these use cases that really is hard to decarbonize and will be even harder to decarbonize by the use of lithium-ion batteries. So I totally understand that the concept of Power-to-X is fascinating, and it's great to hear that it could be applied already today. However, there has been some hype around hydrogen, green hydrogen and Power-to-X before already. So how can we be certain that the hype is justified this time around and that we're really getting started?
Yes, you're right. Hydrogen has been talked about quite often in the past. But this time we think it's different, and hydrogen is here to stay. Since the last year, many countries have adopted a national hydrogen strategy. Among them are Japan, South Korea, the Netherlands, Germany, and the European Union as a whole. And we expect Morocco, China, and Russia to adopt a hydrogen strategy either next year or the year after. Now, the European Union alone has set a goal of 2 times 40 gigawatt electrolyzer capacity by 2030. And this target indicates a cumulative market size for electrolyzers and plants of more than 40 billion euros until 2030. So this is an enormous potential.
Well, that indeed does sound like a sizable and attractive market for local manufacturers to invest in. More important probably even is the perspective from the EU and the significance of Power-to-X in reaching the EU climate goals. How important of a puzzle piece is Power-to-X here?
Now, the European Union has set itself an ambitious goal. By 2050, we want to become the first climate-neutral continent. Wow. But we are not alone. The Paris Agreement is a global one. So we really need to think about how to reach these goals globally. Today, we are using molecules as energy carriers in many areas of our lives. Think about transport or heat in industrial processes. It will be very difficult to substitute these energy carriers just with renewable electricity. Now, Power-to-X is the solution to convert renewable electricity into other energy carriers. Think about the challenges to make aviation climate neutral, or maritime shipping or steelmaking. But even in road transport, liquid fuels will be needed to complement electric mobility. Currently, the European passenger car fleet counts for 270 million vehicles, with 15 million newly registered cars each year. So the internal combustion engine will be around for a while, and we need solutions to use it in a climate neutral manner.
So you've mentioned that there are use cases on the one hand in private transport, but also in some of the really hard to decarbonize industries or use cases such as maritime shipping, steelmaking, aviation. What would that mean if we were able to do that successfully, for example, for the European or for the German economy and job market?
Power-to-X involves a long value chain with all components still present in Europe. Take renewable energy systems, take electrolysis, power-to-E plants, applications and CO2 capture. Now, Power-to-X can defossilize existing industry, and it can be an impetus to create new industrial value chains. So, the Power-to-X value chain can contribute to creating many new jobs. And studies have shown that nearly 500,000 jobs could be created in Germany alone with an ambitious market ramp-up of Power-to-X. Now, this would translate into a demand of 8,000 gigawatt Power-to-X plants worldwide. But also in other countries, Power-to-X could be a stimulus for green growth. We expect that most of the Power-to-X plants will be based in windy and sunny spots around the globe. Take Northern Africa, the Middle East, Australia or Chile as examples. Power-to-X energy carriers could become an important commodity for international energy markets, just as oil and gas are today. And then job potential is enormous.
A job potential that, however, can only be realized if enough countries around the world really place their bets on Power-to-X as well. So what's the situation like globally, Carola? But before we answer that question, it's time for a quick shout out to our partner for this episode, which is SFC Energy, a leading provider of hydrogen and direct methanol fuel cells for stationary and mobile hybrid power solutions. With more than 45,000 fuel cells sold worldwide, SFC Energy is a sustainably profitable fuel cell producer. So let's continue where we left off, Carola. You've already mentioned that a lot of countries around the world are developing Power-to-X strategies. But is it enough really to place our bets in Europe on this technology? Because on the one hand, manufacturers here need global clients. And on the other hand, if we power our airplanes or our ships with synthetic fuels or clean hydrogen, of course, they need to be able to refuel once they reach foreign shores in Asia or America, for example. So is the consensus globally big enough already, or should we rather wait a bit?
As I mentioned before, a number of other countries have already adopted a hydrogen strategy in the last 2 years, and we expect many more to come. But the European Union needs to create a lead market. This is really important. If we signal to other regions in the world that we are serious with our climate ambitions and that there is a need and a market for green gases and fuels, then other countries will take this as a business opportunity. This is already happening, and I can give you some examples. With the support of the German KfW Bank, Morocco is planning a power-to-methanol plant. Chile has announced plans to invest in production plants for e-fuels. And Middle Eastern countries become more and more interested in hydrogen.
And not only Eastern country, but as you mentioned, also Asian countries and specifically China. I think they're hot on our heels when it comes to developing a hydrogen and power-to-X market and economy. They did the same in the solar sector. So originally Germany and Europe was leading when it came to solar. We created thousands of jobs. And then from one day to another, we lost these jobs because China was just able to, on the one hand, produce more cheaply and in much larger scales. So is there a threat of that scenario being repeated when it comes to power-to-X? And have local lawmakers learned their lesson? Or are they just repeating the same old mistakes?
Thank you for this question. I think this is really an important question. Our companies aim for an internationally competitive power-to-X industry that can export its technology solutions globally. And this is why we call for an ambitious market ramp-up in areas where there is a high willingness to pay. There is no doubt that the first power-to-X installations will be costly. So you need to address first movers, which are prepared to pay a higher price. And this could exactly be the road sector. The European Union and Germany, however, want to prioritize the use of hydrogen in areas where there is no or little other alternative. In steel making, in aviation, for instance. Now, those sectors, however, will need a substantial amounts of subsidies to make the change to hydrogen or synthetic kerosene happen. So, at the moment, we rather see a subsidy ramp up and not a market ramp up. And this is exactly what happened in the PV industry, as you said. And our concern is, indeed, that at some point our industry will not be as competitive as others.
Well, that is rather a worrisome insight. However, unfortunately, it's completely out of our hands what regulators are planning to do, so we can only hope that they change their approach going forward. Nevertheless, the numbers, I think, are quite impressive, correctly? So what does the ramp-up look like in numbers at the moment?
Well, the European Hydrogen Strategy has an intermediate goal of 6 gigawatt electrolyzer capacity in 2024. Now, this was announced this summer, and it is very ambitious indeed. To reach that goal, the European Commission launched also the Clean Hydrogen Alliance. This is an alliance of CEOs to fill a project pipeline, if you like. And VDMA is also part of this alliance. Now, unfortunately, the operational work has as yet not begun. And once we start, it's 2021, and we only have 3 years left. So we must not lose more time. But in any case, whether it is 6 gigawatt electrolyzer in 2024 or 2025, it is an important strategic goal for our industry that has to come true. It enables to build up manufacturing capacity, drive down costs, and become more competitive.
So we're almost nearing the end of our podcast, and it's time for some expert-level questions. Where do you stand on the hydrogen color theory? And for those of you who are not familiar with the hydrogen color theory, I'll just break it down on a very basic level. Color theory means that mostly you're talking about green, blue, or gray hydrogen. Gray hydrogen being obtained from fossil fuels, and the CO2 being produced in the process is unleashed into the atmosphere, so it's a very dirty approach overall. And then there's blue hydrogen. Blue hydrogen is also being produced by the means of fossil fuels. However, the CO2 is being stored and captured. And then there's green hydrogen, and green hydrogen is being produced by electrolysis of water, a process being powered by renewable energies. So it is, in that context, the most climate-friendly solution. So back to you, Carola. Where do you stand on the color theory?
The famous color question, yes. Well, both the European Union and Germany set the goal for green hydrogen in 2050. And certainly, there is no role for grey hydrogen in a climate-neutral world. I think this is something we can all agree on. But for the transition, there will be an important role for blue hydrogen in Europe. The chemical industry already uses hydrogen today, but this is grey hydrogen produced from natural gas with steam reforming. Now, in our view, substituting grey hydrogen with blue hydrogen, where the CO2 is stored or used in other processes, will be an important contribution to our climate goals. Also, we must not forget that the Paris Agreement is global and that many countries will be on the path to climate neutrality. There will be many technologies and pathways to reach this goal, and one of them will be blue hydrogen even beyond 2050. For instance, methanol pyrolysis could become a competitive solution to produce blue hydrogen. So, for international industry, as the mechanical and engineering industry, it does make sense to cater to all of these markets.
All right, so if I understood it correctly in my own words, that means that green hydrogen has to be the overall goal if you look at it from an EU perspective. However, in order to reach that goal, and also where not possible, blue hydrogen is the proper intermediate solution, and grey hydrogen certainly is off the table. And if I understood also correctly, then as a manufacturer and as a company involved in the value chain, it still makes sense to cater to blue hydrogen schemes because, of course, globally, there also will be a lot of clients who are not going to move to green hydrogen immediately, but who have valid reasons in order to use blue hydrogen. Speaking of manufacturers and companies in the value chain, in the beginning I already mentioned that the group you represented, the VDMA, which is active in Berlin, Brussels and Europe-wide, you already have more than 120 members. So who do you represent already, and whom would you like to still join your group? So are there some missing links? This is your chance to reach out to our listeners and invite people to join the VDMA Power-to-X applications working group.
We represent companies from the whole value chain, as you said in the beginning. And also we welcome any company that is either a technology supplier, including the components, or companies that are interested in using Power-to-X. So currently we have 120 companies. As you say, we are growing quite fast. But we would particularly also be interested to have companies from the chemical and the energy sector on board. And likewise, while we already have renewable energy plant manufacturers as members, we would also like to strengthen this part of our membership.
So if you're involved in the Power-to-X value chain, feel free to reach out to Carola. Thanks a lot for joining us today.
Thank you.
So what are my key takeaways from this episode? First of all, the hype around hydrogen and Power-to-X in 2020 is justified. We'll certainly see more developments in 2021 as the European Union not only has a dedicated hydrogen strategy, but also is ready and committed to back it up with a significant amount of funding. And so are a lot of other countries around the world. Unfortunately, though, regulation and the way that the hydrogen strategy is being ramped up in Europe might not be the most promising at the moment, as it seems like some of the mistakes that were done during the ramp up of the solar industry in Europe are being repeated, so we can just hope for some fast adjustments there. But independently from that, Power-to-X and hydrogen is being developed globally, so the question is not whether it'll be a significant link in the new energy world, but just basically which region in the world is fastest and will then dominate the market on the long run. Stay tuned for more episodes of the Smarter E podcast. More information about Power-to-X and other storage solutions can be found at EES Europe, Europe's largest and most international exhibition for batteries and energy storage systems, from June 9th to 11th, 2021 in Munich. Everything about the exhibition and the parallel conference can be found online at ees-europe.com.